Hello friends, welcome to my channel. I am Subhrajit Sahoo, Assistant Professor in Narsimha Engineering College. Today I am here to discuss one more topic on this temperature measurement chapter, which belongs to Instrumentation and Control System subject. Today topic is what? Electrical resistance thermometer, right? Electrical resistance thermometer. Today we are going to discuss about this topic. Sir, before that, we have completed the two types of temperature measuring instrument in the last 2-3 videos. What are those? Bimetallic strip and one more is liquid in glass thermometers, right? Those temperature measuring instrument working principle. Now what we are going to discuss, that working principle is quite different, right? It is quite different. How it is differed? In those previous two cases, that working principle is based on mechanical property. Mechanical properties in the terms of metal expansions. Here in the terms of, in the case of liquid thermometers, liquid thermal expansions. That is related to mechanical property, thermal property. But right now, what we are going to discuss, which device we are going to discuss for the temperature measurement, here it is working on the principle of electrical properties, right? Quite difference. Working principle difference, its constructions, everything is different here, right? But same is what? Temperature measurement. We have to measure temperature anyway. Anyhow, we have to measure the temperatures, right? Okay. So this is my today topic. But one more interesting here, what is that? To know about, to study about this electrical resistance thermometer, we should have little bit knowledge on current, voltage and resistance, how they are working, how we are measuring. Like this little bit knowledge we should have, right? As we belongs to mechanical, we have studied one subject, basic electrical engineering, in the earlier semester, in the beginning semesters, but still I will tell some informations, I will tell some important point about this current, voltage and resistance and how we are going to measure all these things, right? Very simple. It is not so difficult, right? Most simple topic. Every chapter in this are one simple chapter, simple topics only. Observe here carefully. Sir, generally Ohm's law, first we have to know Ohm's law. V is proportional to I. Or for a particular conductor, we can say V is proportional to I into a constant. That constant is called resistance, V equal to I. From this, we can calculate R value equal to V by I. This is for a particular materials. It will vary, the resistance will vary, metal to material, it will be vary. Right? Now, suppose in this case for temperature measurement, electrical property principle will be used. Electrical property principle in the sense, whenever there is a temperature change, either increase or decrease, the resistance will be changed here. Resistance of the material will change, either increase or decrease. Okay. And this change in resistance, resistance should be linear once again. Linear. Just in the last discussions also called that expansion rate of the liquid, expansion rate of the solid metals in the case of bimetallic strip should be linear expansion, right? In the same case also, while the change in temperature will be change in temperature will be there, the resistance of the particular material will be changed, and important thing is what? The resistance should be changed linearly. If it is non-linear, then we cannot use the particular metal for the temperature measurement. We cannot use. Always we will choose such kind of materials which is changing the resistance linearly only. Remember, and that kind of materials available in the nature. It is available in the nature. That kind of material it is available there, right? We should know what are those materials. I will tell slowly, but let me finish this part first one. How it is working, how this electrical concept is used for measurement of temperatures. I will tell first, right? Okay. Most important here, a beautiful circuit is used, right? No, a beautiful circuit is used for this concept. The circuit name is Wheatstone bridge circuit. You might have known the construction of this Wheatstone bridge circuit, right? It's a diamond shape. Diamond shape. It is having 4 resistance. Like this, it is having 4 resistance. This is used to calculate the resistance of any circuit, or you can calculate the current also, no problem here. Now, this is the supply voltage supply here. All right. Okay. Now, what type of supply it is? What? Constant voltage. Constant voltage. I mean DC, direct current it want. Okay? Direct current, DC, you have to supply. And here, this terminal to this terminal, galvanometer is connected. G, galvanometer. Right? Galvanometer we are using for measurement of current. Measurement of current measurement, we are using the device known as galvanometer. Now, this 4 resistance in this circuit, I have 4 resistance. Let it is R1, it is R2, it is R3, and it is R4. Out of this 4 resistance, this R1 is unknown resistance. Okay, unknown resistance. R2 is a variable resistance. Variable resistance. And R3 and R4 both are known resistance. That means that value is known to us, known resistance. It is a full bridge circuit. This is a full bridge circuit, right? Now here unknown resistance is 1, that is R1. And this is a variable resistance. Variable resistance example is a rheostat. Rheostat a resistance which is where we can vary the resistance. That means like this, it is one slider will be there. Okay, one slider will be there like this here. If we'll move this slider in this direction to this direction, the resistance value will be increase or decrease based on that the movement of the sliders, right? So we can adjust the resistance by the help of this variable resistance. We can adjust. That's why we have attached here. Now assume the several points here. What? Now the first case is, now the current start. Current supply start. Constant voltage. Now the current is passing here. Passing here. Now at this point and at this point, you assume first the voltage is same. Voltage is same. If voltage is same at this point and this point, that means there is no difference in voltage. Whenever there is no difference in voltage, then no current will flow. No current will flow. So if no current will flow, what will be happen? This circuit, no current will flow. What will be happen, sir? Galvanometer will show the reading 0. Okay, 0. Null position. It will show the reading null positions. Sir, once again I will tell. Now I will supply the constant voltage. Constant voltage I switch on the circuit. Now assume at this point and this point voltage are same. If same voltage, then there is no difference in voltage, so no current will flow in this circuit, in this part. If no current will flow, I can say the Wheatstone bridge is in balance condition. Balance conditions, right? It is in balance conditions, right? Now this is the case. When it is in balance condition, right? When it is in balance condition, 1 minute. I have to take one more minute. When it is in balance conditions, let us derive some equations. What is the equations? If it is in balanced condition, can I write R1 by R2 equal to R3 by R4, right? Those resistance pair connected in series. R1 by R2 equal to R3 by R4, right? That means this end two resistance and this end two resistance, right? We can write like this. If I'll simplify this one, then if I'll simplify this one, what is the R1 value, sir? R1 become R2 into R3 by R4. This is one expression I found. R1 is the unknown resistance. I can calculate the unknown resistance, right? Now this is the case I derived when the circuit is balanced, right? Now again assume here. Suppose I imbalance the circuit by increasing this unknown resistance to del R1. Okay, by any means. Suppose this is, I expose this resistance, this side to high temperature regions. So when temperature increases, resistance increases. So the resistance increases, suppose R1 plus del R1. So once the resistance will be increases, what will be happen? This side voltage and this side voltage difference will be created. Now voltage difference will be created. When voltage difference will be created, current will start to flow. If current will start to flow, my galvanometer will show some reading. It will show some reading, right? It was earlier in the null positions. Because of this del R1 changes, what will be happen? The voltage difference will be created here and causing a current flow in this line, in this circuit, and the galvanometer will be show a deflection, a reading will be shown. Now what I will do, how much this del R1 increases, I don't know. This is unknown, completely unknown. How much this del R1 is increased or decreased, I don't know. This is completely unknown. Then what I will do? What I will do, sir, again I will try to make this total circuit to balance. How, sir? How I will make it the total circuit to balance? Because I have a variable resistance, right? I have insert a variable resistance knowingly. So where I can vary the resistance, increase or decrease the resistance. What I will do, sir, if I saw the circuit become imbalanced, to make it balance, I do some variation here. Let del R2 variation I do. Okay. I do some variation here, del R2 variation, so that it again come back to null position. Again come back to null position. Right. That is again come back to here null position, right? So when at this condition again, and this del R2 value I know because it is a rheostat, right? How much variation I will do, I can see here, because here some measuring, marking will be there. I can see here how much variation I am doing, how much decreasing, how much increasing. I can record here, right? So I adjusted this variable R2 resistance in such a way that del R2 adjustment I have done, so that again the circuit come back to the null positions, right? Now in the second case, let us derive some equations. Let us type some equations. Again, my circuit is balance conditions, but in that balance conditions, what is the resistance value, sir? R1 become R1 plus del R1 and R2 become R2 plus del R2, and as it is equal to R3 by R4. If I'll simplify it, this one, what output I will get, what answer I will get, R1 plus del R1, this is del R1 actually, equal to, this will be multiplied, this term will be multiplied here, right? So here I will write directly R2 into R3 by R4 plus del R2 into R3 by R4. And just I open the bracket and pass the multiplications to this term, right? Okay, anyway, now see, observe this R2 by R2 into R3 by R4. What is this one? This is this value, right? R1 value, right? So I can write here R1 plus del R1 equal to R1 plus del R2 into R3 by R4. Now R1 get cancelled. Now what is the del R1 value, sir? Del R1 value is del R2 into R3 by R4, right? Del R2, you can able to know how much you are varying the resistance, and from beginning I told R3 and R4 value, R4 are the two known resistance here. See, R3 and R4 value are two known resistance, and how much del R2 you are doing, from this you can observe. If you can observe anything, can you calculate how much del R1 value, how much variable resistance changes? Okay, and for that resistance changes, how much current deflected here also, how much current deflected here also you can measure recording. That means everything you can track here. This is a very beautiful concept, right? Everything you can track here. Later, this changes you can convert it to in the terms of temperature, in the terms of temperature measurement. This is the concept of electrical resistance temperature, right? Electrical resistance temperature measurement technique, right? So this is a little explanations about the Wheatstone-Bridge circuit, right? And here, suppose R3 equal to R4. Now all resistance are same. R3 equal to R4. Then this two term will be cancelled. Suppose the two known resistance value is same. Then it will cancel. Then what is the del R1 value, sir? Del R1 equal to del R2. Simple. I can calculate like this, right? Like this I can calculate. Okay, anyway. Now, what is my topic, sir? My topic is, now this concept we are going to use in every electrical resistance thermometer. Okay, not only in the electrical resistance thermometer, in the coming days we are going to discuss the strain gauge also. Same concept we are going to use in the strain gauge also for measurement of strain also, right? Our topic is electrical. This one is my topic, right? Electrical resistance thermometer. Sir, what are the things we are going to study here? We are going to study here one more device, thermistor. Okay, thermistor, and as per your syllabus, thermocouple. Okay, both are working on the principle of this electrical property only. Electrical property only. That means some voltage, current, and resistance related terms will come here, and here we will explain all these things. And here one more important point I will tell. What is that important point means? We should choose such kind of material from the nature which are very much sensitive to resistance changes. Okay, resistance changes. When temperature will be changed, resistance should be changed, and the resistance changes should be linearly only. That kind of materials we should choose. What are those materials? What is the working principle of thermistor, and how thermocouple is working, application, advantages, disadvantages, everything I will tell in the next video, right? I will conclude here. Till then, you take care and bye.